The fourth drug of the industrial production is the Diosgenin. So, as the name suggests, the Diosgenin, the biological source of this is the Dioscorea deltoida, and the family it belongs with the Dioscoreaceae. It is a steroidal sapogen which is obtained from the tubers. So, the industrial production will start with the tubes of the Dioscorea deltoida. If we see the industrial production, the process is used in the industrial production is the acid hydrolysis. So, the coarse powder of dried tubers hydrolyzed with the 2.5 normal hydrochloric acid by either reflux or autoclave for 1 hour. For 1 hour, the hydrolyzed mixture filtered and washed with 10% sodium bicarbonate to neutralize the acid. Later the washed with water, dried at 50 degrees centigrade. So the hydrolyzed tuber powder extracted with benzene for 6 to 8 hours, and these benzene extract filtered and concentrated. Later, the residue dissolved in chloroform, and the chloroform fraction concentrated and purified by recrystallization in acetone. So, if we see the estimation process, we use a HPTLC method, and for the preparation of test and standard solution, we are taking a 6 gradual increased concentration of standard diosgenin were prepared in absolute methanol. Similarly, a predetermined concentration of isolated diosgenin solution prepared and used as a test diosgenin. The experimental conditions for HPTLC method is for the mobile phase we are taking a concentration of N-hexane with ethyl acetate, and the ratio for both is 4 is to 2 volume by volume. The stationary phase is the silica gel, that is F254. The derivatizing and visualizing agent for the experimental condition is 3 gram of antimony trichloride in 100 ml of hydrochloric acid. So for the test diosgenin of known concentration applied on a pre-coated silica gel, that is F254 HPTLC plate, along with the series of gradual increasing concentration of standard diosgenin for quantitative estimation. The plate is developed in saturated HPTLC chamber with mobile phase. After ascending development, plates were dried and derivatives in antimony trichloride in HCl. Diosgenin developed greening black color spot. So it has been a well defined color, that is a green black color. For qualitative estimation, derivatized plates scanned using a densitometer. So there is a new method, that is a densitometer, we are using for a quantitative estimation, and for that we are taking a calibration curve of the peak, that is a area under curve versus concentration of the standard diosgenin. So the area under curve of the test diosgenin extrapolated on the calibration curve to quantify it. So this is a method for estimation of diosgenin. So the diosgenin, it is a saponin. So these are used as a precursor for steroidal synthesis, and it is also used in the synthesis of sex hormones and in preparation of the oral contraceptives. Diosgenins may behave as a prodrug to progesterone, and the Dioscorea tubers are traditionally used in the treatment of rheumatism. Next drug in the series is the dioxin. It is a cardiac glycoside which is obtained from the leaf of Digitalis lanata belonging to the family of Scorophileraceae. And for the industrial production we have a two method. First of all, from the leaf extract we have to take a extract of lantoside C, and then after that we can do a two process in a vice versa. Like first of all we are doing a alkaline hydrolysis and then enzymatic hydrolysis, Or we can switch the method. First of all, we take a enzymatic hydrolysis and then the alkaline hydrolysis. Let's see. For the estimation method, industrial production, we are first taking a fresh leaf which is made into a paste and treated with the neutral salts to inactivate the oxidase enzyme, which is responsible for the conversion of glycosides to glycogen. The salt treated paste either deflated first with benzene and followed by extraction with ethyl acetate, or directly it can be extracted with ethyl acetate. The resultant extract contain a lantoside C, which needs a further purification. For the purification, we are using a recrystallization and a chromatographic purification yield, which after hydrolysis yields a dioxin. Next is the estimation method. This method has been taken from the IP 2007, and for that we are taking a test and the standard solution. First of all, we weigh accurately about 40 gram of test and standard Diosgen and dissolve in a sufficient ethanol, that is 95%, to produce a 50 ml, and dilute with 5 ml of this solution to 100 ml with the same solvent. Next is the assay. For the assay method, we are using a 5 ml of resulting solution and adding a 3 ml of alkaline picric acid solution. Then after that, we will allow to stand in a subdued light for 30 minutes and measure the absorption of the solution at the maximum, about 495 nanometer, using as a blank a mixture of 5 ml of ethanol with 95% and 3 ml of alkaline picric acid solution. After that, we will calculate the content of the dioxin from the absorption obtained by repeating the operation using a dioxin versus in place of the substance under examination. So for the percentage assay, we will calculate by taking a sample absorption, which has been divided by the standard absorption. We will multiply the standard concentration and the sample concentration into 100. So the utilization of the dioxin is used in the treatment of the cardiac disorder, and it is used in the to treat the heart failure, congestive heart failure, arterial fibrillation and arrhythmias. So most important use of the dioxin in the cardiac disorder.